All right, ladies and gentlemen, we're back. Another video. Mr. Zabrankos is actually helping us with another measurement. We currently are going to show you how to observe the narrowband oxygen sensor signal. And if you remember your narrowband oxygen sensor signal upstream, B1S1, which is that sensor right there, it's a narrowband which operates from 0 to 1 volt. When it's lean, 0 volts. When it's rich, potential difference in oxygen ions, you're going to see voltage produced up to theoretically 1 volt, okay? Stoichiometric is obviously around 450. What we did was you're using the same thing, that 4-channel oscilloscope that we have. In channel A, using that BNC lead, the yellow colored BNC lead, leading up to here, basically, Neil just back probe the sensor output on the O2 wiring harness, which is the blue wire. That's your sensor output. And then the other end of your BNC wire is just connected to ground. So even though it's yellow and black, this is essentially the red and black of your multimeter, okay? And that common ground grounds out your scope, all right? So that's how you would do it. You have to make sure it's heated up. This is going to be one of your practical tests, but it's also very important in the real world so that you need to be able to monitor this voltage, because using a multimeter, min-max is a little slow. There's too much latency. Okay, so Mr. Zabrankos, do you mind, maybe you can hit play, and then we'll talk about the settings that you have this set on, okay? Okay, 1 second per division. So each section on the time scale is 1 second. 1 millisecond, sample per millisecond is the sampling rate, plus or minus 1 volt. And what he selected here in channel A, you just use the 1x. You just use the 1x. And I recommend activating filtering, right? Kind of cleans it up a little bit once you pause the video. All right, other than that, make sure it's DC, of course. You're doing DC volts. Okay, these are the settings. You'll learn how to do it. And if you're unsure, the quickest way is to hit automotive measurements, and then you can pull down to zirconia. You can do it that way. Okay, so right now it's oscillating. It's a little bit slow. You want to bring the RPM to approximately 2,000 RPM and just hold it. Right, that's the engine running stoichiometric. It's alternating between 0.3 to 0.7 approximately, and then the midpoint should be 450. 450 is stoichiometric. Now the O2 responds to throttle situations too, just like the test you did today. We're going to do a full enrichment circuit. I'm going to snap the throttle. Okay? It goes down, went up. See, watch. There. That's enrichment, right? That's your enrichment circuit. Accelerate, off throttle. It goes lean because of field cut. Then it goes back to oscillations again. Okay? Now, for your practical, I want you to get a nice picture like this. So, Neil, I'm going to get a nice picture. You pause it when you think it's good. Perfect. That's good enough. So he paused it. This is what I expect you to do. You bring a nice picture like that. You're going to move your voltage cursors. Notice how one says 1. So your 1 will be on the low range. All the way down so you can touch as many as you can, the low end. Then bring the other cursor. That tells you the total amplitude. So it goes as low as 68.97 millivolts, as high as 730 millivolts. Total range being 662.8. If you want to take your total sweep of 731 millivolts divided by 2, and you approximately have a little bit around 300 some odd millivolts. This engine is running a little bit lean because it has vacuum leaks, I believe. Not running exactly 100% tip-top shape, but that's essentially how you want to hook up your O2 reading.